Hello, my dear students. Welcome to lecture number 18 on the part light reflection and refraction. In the last lecture, we were studying the image formation by convex lens, where we came across when we place the object at infinity, when we keep the object at infinity, we get the image at second principal focus, that is f2 over there. Size is highly diminished and point sized, and it is real and inverted. So you got the image which is at second principal focus f2. Size is highly diminished and point sized, and it is real and inverted. In the second case, when we keep the object beyond 2f1, when we place the object beyond 2f1, what we get? The image is between f2 and 2f2 on the other side. The size of the image is diminished in comparison with the previous, and the nature is real and inverted. Similarly, when we keep the object at 2f1, so the image is at 2f1 only. In fact, that is 2f2. I'm sorry, it is 2f2. We get the image at this position 2f2. The size is same as of the object, and it is real and inverted yet again. And we also got how to draw these diagrams with respect to their positions, how to get the image. So all those we discussed in the last class. In this session of the lecture, we are going to continue the rest positions as well as their images respectively. So we are into the next position of the object. It is between 2f1 and f1. So whenever you are placing the object between 2f1 and f1, you will get the image beyond 2f2. Beyond 2f2, you are getting the image beyond 2f2. So how? Here the ray of light, which is parallel to the principal axis, after refraction through the lens, it will move from this portion f2, second principal focus, and it will move like this. And on the other hand, the ray which is passing through the optic center, which will go undeviated. So if you continue these two, it will intersect at this point a dash. So you call this as a dash and b dash. A dash and b dash is the image of the object AB. Okay, so the position which we got, that is beyond 2f2, size of the image is enlarged this time compared to the object, which is bigger, and hence the size will be enlarged. And the nature of the image is real and inverted. So you are getting the inverted image of the object. Okay, so let us try to draw this. So first what you do, you just draw the convex lens, then then you need to draw the principal axis, mark the optic center O. Here it is f1, the first principal focus. This is second principal focus, 2f1, and here it is f2. Similarly, you have 2f2 here in this case also. So what happens? What you are doing actually, you are placing the object in between 2f1 and f1 like this. This is your object AB. So the ray which is parallel to the principal axis, which will go like this, after refraction it will pass through the F2 line and it will continue like this. So this is the ray which is passing through the what? Passing through the lens, and hence it is moving to the principal focus number 2, that is F2. And on the other hand, the ray which is passing through the optic center O, which will go like this, and just you drag the principal axis if you can. If you drag this, then you will have the image somewhere here, intersected point. This is the intersection, so you will have the image on that position. This is B dash, this is A dash. So here AB is the object and A dash B dash will be your image. So as I said that the image position is beyond 2F2, beyond 2F2. Nature is real and inverted, and size is enlarged in comparison with the object. I hope you got how to draw this part as well. So the next position, that is position of the object, this time at F1. You are placing the object at F1. So once you place the object on F1, first principal focus, the image is going to shift at infinity. Image is going to meet at infinity. This is the exact opposite position to the first case. So when the object was at the infinity, you are having the image on principal focus on the other side, no doubt about that. So this is a bit reversal, no problem, but the image is going to form at the infinity. So if you get that image right, that is highly enlarged. The image is highly enlarged and the nature will be yet again real and inverted. If you get that position at infinity, you will have the image real and inverted. What did you do here? That is, the line which is parallel to the principal axis again move like this. After refraction, it will pass through second principal focus F2, and the O, the line, sorry, the ray which is moving from optic center O, which will continue like this, and it will move somewhere at infinity. It will meet at infinity. So this is very simple diagram to draw. So let's draw that. Again, this is the convex lens. This is your principal axis all the time. Once you got practiced, then no problem at all. So this is F1. This is 2F1. This is F2, 2F2. So you keep the object on F1. So you are placing the object on F1. This has to be your object A and B. So the ray which is parallel to the principal axis will pass through F2. It will continue like this, and on O, the ray of light which is passing from O, it will go undeviated. So if you want to mix this, that should be at infinity. So you are getting the image is at infinity. So as I said that infinity may be a window of your room, or it may be a tree, it may be a building, as I mentioned in the, remember you cannot draw parallel because parallel lines never meet, but you just make a cross like this, something like this. In the end it is going to meet, sorry, the rays will meet at infinity. So you need to plot like that. So keep always in mind that about the indication of the arrow is important along with this ray. I hope you are getting this type of image right. Now, what we are doing, we are bringing the object between F1 and O. So we are placing the object between F1 and O. First principal focus F1 and the optical center O. So what it will do now? See, when you place the object between F and O, the image is not going to meet at infinity, it shifts on the same side of the object, keep in mind. So, when you bring the object between F and O, which can be compared with the mirror to concave mirror case, when you are bringing the object between F and P where the pole is there, so what happens? It shifts behind the mirror, but this is exactly opposite. So anyway, it is whenever you are bringing the object between F and O this time, it shifts on the same side. So in such case, that is reversed on that occasion, no doubt about that, that behind the mirror. Anyway, you can compare. So what you do, the position of the image is on the same side of the object. Where is the object? On this side, the AB will be your object this side, sorry, AB, this is the object. So you place the object between F and O, therefore AB, the image is on the same side of the object. So size of the image is enlarged. This time nature is going to differ. Nature is virtual and erect. So what you do, you just plot the ray which is parallel to the principal axis. It will go like this. So after refraction it must pass the F2, no doubt in it, and similarly from O, no problem, you just carry on this side. What is the next step? You just drag this point up to this somewhere, so F2 line is drawn back like this. Similarly, the line or ray which is passing through O, if you drag this out, it will meet on one point, so that is intersecting at this point. This is virtual, remember, this is virtual. So you will get the image A dash and B dash here. So dear children, take care that the image is on the same side of the object. Image is on the same side of the object. Don't worry about their positions in this situation. So you can just take it is on the same side of the object which is enlarged, and the nature is virtual and erect. So how to draw this? Again, this is simple way. You draw this convex lens, go through the principal axis. This will be your optic center O, this is F1, this is 2F1, here it is F2. I think this portion is not required in this situation. Anyway, whenever you are bringing the object in between F1 and O, make sure that please do not draw bigger, object bigger. What happens if you enlarge the size of the object? It will go beyond your pages. In my situation, it will go beyond the slide. So what you do, there is a small trick. Reduce the size of the image. Okay, by that you can draw it easily. So first, what needs to be done? This is the ray which is parallel to the principal axis. You need to write. It will go through F2. Just you drag it out if you can, somewhere here. Okay, so on the other hand, you have the ray which is passing through O like this. You just drag if you can. So somewhere here, assuming you will have the image like this. So this is B dash, A dash. So A dash, B dash is the image, AB being the object. This is how we are drawing this. I hope you're satisfied with the way we are looking into it. So this is about the image formation by convex mirror at different positions. I hope you got all these points. The next portion, that is image formation in lenses, that is concave lens. We are into the next part, that is concave lens. Concave lens is a diverging in nature, therefore you will have the image which is comparable to the convex mirror. Okay, so the following illustrates the ray diagrams for image formation by concave lens. Sorry, it will be concave lens for various positions of the object. So when you take the object at infinity in concave case, the image is going to form on the same side of f1. So first principle focus on f1. This is the diverging in nature. As I said that for such situation, the object is at infinity means the ray is in fact parallel to this principal axis will refract and diverge like this. It will go like this. Similarly, we have on the another side. So this is the another ray of light which is parallel to the principal axis, diverge like this. So once you get back these things, so you will have the image at f1. Okay, you will get the image on the same side. Remember, you are getting the same side of the object this time. In concave case, it is all the time the image is on the same side of the object. Okay, and the size is highly diminished and point sized image, since it is on the same side, virtual and erect. So how to draw this? This time we are having concave lens. So this is your concave lens. It is drawn like this, thinner at the middle, thicker at its edges. Again, you go through the principal axis, mark the optic center O. You just carry because you are taking other part too. So this is f1, this is 2f1. The ray of light which is at infinity, remember object is at infinity, the ray which is coming from that side enter into the lens. Since it is divergent in its nature, it will go like this. Similarly, we can take this side also. So it will go like this. If you bring these two in, if you drag back, you will have the image at f1. You will get the image at f1 position, which is on the same side of the mirror. Okay, I hope you got this step right. Now we are having the second and last position here, because from infinity, from the previous point to the optic center, now wherever you place the object, you will see the image between f and o only. Keep in mind, after infinity, the positions after infinity, you just take it as infinity to o, no problem. But from that position, compared to the previous diagram, from that position to the optic center, say beyond 2f1, at 2f1, between 2f1 and f1, at f1, between f and o. So wherever you place the object, you will get the image between F and O only in case of concave lens. In case of concave lens, place the object wherever you want from infinity to O. You will have the image always in between F and O only. So the size is diminished in nature all the time. Sorry, it is diminished. Nature is virtual and erect all the time. So what you do now, just place the object. For an example, between 2f1 and f1, you place the object AB between 2f1 and f1. You draw this line, this ray of light, the ray of light which is parallel to the principal axis. After refraction, it will go like this. So bring that back at f1 here. On the other side, if you plot the optic center O like this, it will cut the portion here, it will intersect. At the point of intersection, you will have the image A dash and B dash, which is diminished, which is smaller in size, and it is virtual and erect. So this is the position of the object at infinity and the image characteristics. So how to draw this? So how to plot this? Just you need to draw concave lens here, and later you need to put the optic center here and mark the rest. This is O, this is F1, this is 2F1, here it is F2 and 2F2 somewhere here. So you place the object anywhere from infinity to O. I am placing as an example between 2F1 and F1. I am placing the object like this. So what it does, the ray which is parallel to the principal axis, after refraction it will move, actually passes through F2, but this is the divergent lens, therefore you can draw like this. So once you drag back, it will coming from that point, and on the other hand you have the ray which is passing through O, which will go undeviated. So this is the portion where you are getting the image A dash, B dash. So the nature is smaller or diminished and virtual and erect. I hope you got all the points which I have discussed today. If you are having any queries or any problems or any doubts, so please, again I am urging you that make use of your WhatsApp or Google Classroom. So try to solve your problems, try to get the answers for your doubts. So with the next points of this topic, I am going to meet you in the next period. Till then, take care of yourselves. Bye bye.